Okay, thank you very much. Good morning. Special welcome to those of you like me who've just arrived from America and are feeling like going to sleep right now. So I asked, what am I supposed to talk about today? And they said, well, there's two things. There's a few people in the room who might not know who ARM is. I thought, well, it's a little surprising that you've bothered to come here and you don't know who we are. But so I've got a couple of slides on that, and then please talk about anything you feel like. There are lots of seats down the front, all of those standing at the back, the whole front row where you can abuse me from. So that said, let's talk about ARM. So ARM started 1990 as a joint venture between Apple and Acorn, and I was one of the happy band that was part of that original founding in 1990. And you know, the story is quite simple. Get yourself designed into Nokia and mobile phones. Good to choose the right market segment with what in those days was the right market leader. And then you end up growing yourself to a billion-dollar company. So quite an easy story for how to be successful. And where we've ended up, of course, is 70% of the world's population actually using ARM technology. And if I go back to 1990, and go forward just 1 year. I quite like this. It's the Radio Shack advert for 1990. And, you know, phones do feature on it. You'll see it there in the middle. Of course, it fitted in your car. It was a car phone, and the phone was in the car, but in the trunk, in the boot, was the actual mobile receiver and transmitter, size of a small suitcase. They were just starting to phase out in that time, which is why it was only $200 in those days. But what I'd like you to do is look at everything else that was on that page, everything from calculator to camcorder, and we'll come back to what's happened to that technology. So designed into a Nokia mobile phone in 1993 through to 95, but volume didn't really start arriving for mobile phones until 1997, where we shipped a glorious 10 million units in total. So 1990 to 1997, 10 million units, and we felt pretty good about that. That was a big number, in some senses way more than we ever expected. And if you run that forward to 1997, we passed the threshold of our partners shipping 10 billion units. And by then, we kind of knew that the mobile was taking off as a real market. And then you get to 2007, and of course, launch of the iPhone, which changed, I think, for many people, phones from being communication devices to the mobile computing platform that they are today. And as that wave cut in, volumes had got to, in 2017, 100 billion. And if you look at a mobile phone today, it is all of that technology that was being shipped in 1991, integrated and put into a single device. So a simple story of ARM, and I thought I'd use one slide from the ARM marketing department. You know, the architects of global opportunity. There's no way I could have come up with a catchphrase like that. And we are the leaders in licensable technology. We don't make anything. I really was yesterday having a discussion with the taxi driver who knew who we were because he was taking me from the station back home here in Cambridge. And he was asking, well, where is your manufacturing? And I said, well, we don't have any. And I had to explain to him that, you know, we just do design, we just do licensing, and that's what our business is all about. And we think that that is a way of enabling other people to do creativity. We don't design mobile phone chips, we design microprocessors. We allow everybody else to add their own value and differentiate around that. And I think the thing that makes ARM different from a lot of other players is that freedom to innovate, is the fact that we define the part of the platform that we know and understand best, but leave it to others to actually innovate around that. And so we have always, from the very beginning, thought of this as a partnership business model. The way we make money based on license fees and royalties ensures that we have to make our partners successful, because if our partners don't actually ship chips, we don't get paid the royalty, and royalties are where the real profit that we make comes from. So we enable people to partner with us, and I think over the years that has expanded out from our direct customers and partners through to the kinds of events we see here today with universities, making sure that people can innovate around the ARM platform, both to make that platform better and to then create completely orthogonal things using our technology as just a base building block from which to do the innovation that you do. So that's all I'm going to say about ARM. And I got to, well, what am I going to talk about? And I kind of have the usual sort of blank moment of, really, let me see. I've talked about IoT too much. Last year I did a whole bunch of healthcare, and I looked at today's program, and we have Haiyan who's going to talk about healthcare. So I thought, no, okay, I can't do any of my healthcare stuff because we might disagree with each other or contradict or just be boring. So I thought, I better do something different. And as always, what I've done is I've retreated to a bunch of news headlines that I've seen, and I'm going to use those news headlines to kind of kickstart me into talking about a few things I think you hopefully find interesting. So the first one was something I have no interest in whatsoever, sports. Frankly, no interest in sports. But I happened to be pointed at this headline, and I thought esports, and I'm of an age to kind of go, esports? What's that? That's really a thing? You really watch people play video games? And the answer is yes, Mike, you're old, and yes, it's going to be a real business. So I kind of looked at it and went, you know what, they're right. Here is an esports stadium being built in China. It's going to be one of the biggest in the world. And that's the point where you think, yeah, okay, the world is changing. There is innovation going on that we might have enabled, but we certainly don't own or control. So esports, and I'll come back to it because it kind of got me down the life of crime. So I went from esports, and I thought, okay, look at gaming. And then you look at gaming, and you work out how many players were banned, and the numbers are simply shocking. That's 1 million banned in 1 month. And you do the maths, and it works out that if you can find a way of finding a cheat for the game, finding a hack in the game that allows you to apply that cheat, then you make your virtual currency and exchange it for real currency, and before you get locked down, you can make enough money to pay off the original price of you buying the subscription for the game, okay? And it's a real business. And it affects people in this room because, as I'll come back to, architecture improvements for security of running apps on gaming platforms is something that we're interested in. There is real computer science to be done there because it's costing people a lot of money. And so, it is computer science tied to crime. And I read this one, Internet of Animals. I thought, no, it's gone too far. It's gone too far, and I'm not going to talk about the Internet of Animals. But it did kind of put me down the road of looking at research into predictions about the internet. I thought, okay, that's more interesting. And I came across this guy, and this is 2001. Okay, so if you could think back to what were you doing in 2001? And what was your view of what the internet was going to do in 2001? And his main prediction, which I really liked, was this. People have started to worry about computer attack by terrorists, but what you should really worry about is hacking of elections. Now. Like many academics, you might say a little ahead of his time. And as we know, turning ideas into money is about timing. But I kind of started reading this and thought, okay, I hadn't worked that out in 2001. Thank you very much. And then he went on to make a bunch more predictions, which I'll let you read because this is the point that I was told, Mike, you're not supposed to do religion and politics. Okay, but I thought this really was, the research end of academia that actually struck a chord with me about worrying about what we do as technologists, what are the social issues that actually raises, and we can't just do the technology. We have to think about what that will do, because some of the way we frame technology can actually change what the impact is on society. And I'll come back to that point in a little while. So I thought, okay, what were the predictions I have failed to make? Now, every year we have a meeting like this, but for our partners. And the first ever one we had of that was in 1991, when we had precisely one partner, which was VLSI Technology, but we got together with them in a room, and now we have hundreds. And frankly, when we started ARM, I would have never predicted that we got there. So that's a prediction I got wrong in 1991. I would never have said that we'd have 500 customers 25 plus years later. So another prediction I might have made, and in some senses I didn't think about it, is would I have written the presentation I've done today on an ARM-powered laptop? Well, the answer is yes, I would, because at the time in 1991, we were, of course, using ARM-powered, they weren't laptops, but they were ARM-powered computers, because in those days we still had the remnants of Acorn when we had designed our own chips, our own operating system, our own application software. So we were using ARM computers to do our work, but I would never have thought that it would actually be running Windows 10. And I certainly didn't say that I could have run the same presentation software and edited on my phone that presentation. So I got that prediction wrong. And if you look at the early days of ARM, our logo used to be all uppercase Times New Roman rather than fancy font and lowercase, and that's how fashions change. The route from initial design through to starting ARM in 1990, what we said from the beginning was there's RISC, there's CISC, and most people were using CISC architectures and then transitioning to RISC to go, how do I make the most power performant chip on the planet? And we were trying to do something different. They were all going for performance, we were going for the balance of price and performance. That's what made ARM technically different from everyone else. We weren't going after the workstation market. We weren't trying to have the world's most powerful computer. We were trying to find a balance between price and performance. That turned into price, performance, and power. That's got us where we are in embedded and in mobile. And I guess the point here is, it's good sometimes to work out what can make you different from everybody else, what can actually give you that unique advantage. And I think that applies to research as well. If you're just doing the same as everybody else, it's going to be harder to break through and find something different. Some of the most interesting research is where you take off and find some balance between two opposing forces, and how can you find a different balance between those opposing forces. And our mission in those days, oops, wrong button, to design competitive low-power microprocessor and the system components that goes around it hasn't changed. So it's a mission that's actually stood well for 25 plus years. Now, the very first conference I ever gave a keynote speech at was Microprocessor Forum. And they had the best ever giveaway. I must confess that this year you get a small rechargeable power bank. I got this, and everyone who gave a presentation at the conference had to be announcing a new microprocessor, and they had to provide the silicon of that microprocessor, so all of them could be put together in this Lucite block. And it was my first ever real big conference that I'd spoken at, and I was pretty scared, and ARM was the outsider because nobody really knew who we were and why we were there, but fortunately we got invited. And I'd just like to look at all of the chips that were being launched in 1992 and the architectures that they represent. And some of you may remember some of them. And, I, again, would never have predicted that 25 years later, there's just those two of us left. And, again, a prediction that I got wrong. But if you go back to the very beginning of ARM and our first microprocessor, 3 micron, ARM1, it was just called ARM in those days, it's been rebranded to be ARM1 to fit the story, and follow it through with process shrinks to Cortex-M0, which in a lot of ways is the same thing as the original ARM1, similar number of transistors, targeted at embedded rather than a desktop computer, so some of the architecture trade-offs are different, but very similar design. And then you go, well, how do we do with Moore's law? And you do the 3 micron to 10 nanometer scaling, and you divide it, and if you say, let's go for rewriting history and Moore's law doubling every year, you come out at 2.04 years. It's kind of held together really surprisingly well. And if we take Moore's law and look at the feature size report on gate length in 2003, there's that kind of constant tick, tick, tick of Moore's law's getting better. And then you run it forward to 2015, and there we go. Flattish. We had flattish at best. And Moore's law is slowing, Moore's law is dead, Moore's law is over, however you want to put it. And on one level it's true, but I'd say, as certainly from my perspective, and I hope from ARM's perspective, we don't care. And so I think I need to explain to you, why don't I care that this is what's happening to Moore's law? And it's quite simple. There's this kind of 5-year cloud of visibility that we always have over what the technology can do. And let's take CMOS and say, yeah, okay, it's kind of flattening, right? And just accept that's what's going to happen. Well, for embedded, which is where 70–80% of ARM chips actually get shipped in that microcontroller market in embedded, that's fine, because the technology being deployed there is sort of 90 nanometers. There is another 10–15 years of process technology that hasn't yet been exploited. Now, the modern technologies are really expensive, but there's the other law about manufacturing efficiency. It's just getting more and more easier and easier to make those high-tech processes as it becomes just a manufacturing problem. So the cost of the high-tech processes is going to fall. The embedded roadmap, I think, is there for many, many years to come. And so the embedded market has future technology in front of it. It's just a question of the pricing becoming acceptable. So embedded has loads of growth in it. I don't think you need to worry about it. Then there's a whole bunch of stuff happening in 3D. Whether that is, within the silicon and 3D transistors, stacking within a die, stacking dies together. It's become a reality in how you manufacture flash chips. It's a reality in what you do in big servers now, where you actually take your large multi-core CPU and cut it up into 4 smaller ones and stack them. And the yields go up, and you actually have better performance and higher yield by starting to stack those processors with memory. So I think, infrastructure, it's on the leading edge, it's expensive, but you can see how 3D technology buys you a good few generations yet to come. And then you kind of get to places like mobile, and last year, what was I talking about? Machine learning accelerators. There's a whole bunch of compute now coming, which is it's slightly harder. We have to think about it more. It's not simply take your RISC engine, make it run faster, have yet more inefficient software written in C and get on with it. You actually have to step back and go, okay, what are some of the tasks we're doing? How can we actually architect better accelerators to solve specific tasks? And you build accelerators. And again, it's a way of putting brain cycles into solving computational problems that isn't just brute force and transistors. So I see there's a whole growth in mobile that's based around all of the underlying technologies and doing better things in how you actually design systems. So, mobile's going to push forward as well. And then you get out of that 5-year gap and, neuromorphic, spintronics, revolutions in the way analog work, all the way through to, quantum, photonics. There is technology out there. There is going to be, in the 10, 15 time frame, new technologies that take us beyond CMOS. And the conclusion of that is, end products, as bought by people like you and me, are just keep going to get better and better. Our jobs might be getting harder and harder, but from a consumer's perspective, there isn't going to be a slowing down. Moore's law might do this, but consumer and industrial products, as delivered, are going to have more and more performance and do more and more. There isn't some sudden kind of death in the industry where innovation stops. It's just the way you do innovation is going to have to change, and it might get a bit harder. Sorry, get over it. So come back to fraud. This headline took my fancy. Not because it had big numbers, it's just a UK number about fraud costing billions. But it was the observation that from the state's point of view, it's our problem. This is not conventional crime where the police will tidy it up and it'll be all right because somebody else is going to take care of it. Actually, fraud and the things related to it are going to be our issues to solve. And that's why, as researchers and designers and producers of products, we actually really have to think through what are the systems we're building and what are we doing to make them secure, because it's not something that after the event somebody else is going to come in and fix. Which takes me to what is my favourite product of the year. Every year I like to have a favourite product, and this is my favourite. It's not perfect. You read the reviews and some people moan about it, but for me it's been a brilliant product. Thing. You can buy it on Amazon, relatively cheap. Small little box that you just plug into your home network, and you can do interesting things. It'll tell you who you're connected to, and it'll run regular speed checks so you can see what is your performance sample through the day with a nice little noddy, easy to use UI to plot you nicer graphs. And what devices are connected to your network at any one time. So if you can't remember what the IP address is, you can go and have a look at it. And you can select a particular device, perhaps your wife's friend and her mobile phone, and maybe you don't get on quite so well with her as other people. And you can then kind of go, well, I'll just tick the box that says, alert me when state changes. So you can get an email when she comes, and you can get an email when she goes. I'm not saying this is police state, but it can be quite useful. And then I've got a flat in London, and if you're really sad, you can say, please monitor all of the Wi-Fi devices that are detected by your hotspot. Don't actually let them connect, but what devices come past and just kind of go, hello, I'm a Wi-Fi device. And this is, I back onto a park, and what you can see is there's throughout the month, how many devices in green and blue has it seen before, because it remembers all the devices it's ever seen, which are new and which are returning. And you can see that the park is busy at lunchtime and early evening, and a lot of that is people commuting through the park because it's a shortcut, and some of it people just coming up to eat their sandwiches in the park. And about half of them are regular visitors that work in the businesses around it, and about half of them are just people who are coming and going. So if you want to kind of understand what is happening in your environment, it's a lovely device. What you should have paid attention to is this little detail up here. 17 devices of 109. And this is of my holiday home. And I kind of went, hang on, my holiday home. Okay. 109 devices. No, I've got 17, and there's 4 members in my family. How do I get to 109? You very quickly go, oh, well, my friends had some friends come down, and then my wife has 3 sisters, and the 3 sisters have a spare key, so they have friends that come as well. And all of a sudden you go, there's about 80 devices there that have connected to my network, and I have no clue who they are. Not to worry about that. And it's quite easy to manage visiting Wi-Fi devices. You go, okay, I'll create a guest network and that'll segment it so they can't actually see my servers and any of the local things. They just get free Wi-Fi. That's fine. And then you kind of go, well, what about my Nest? That connects via Wi-Fi. How much do I trust it? Well, okay, I could create another Wi-Fi network for the devices I sort of trust that I want to put on my network, but I'll put it on a different Wi-Fi network so I can do some partitioning with it. Yeah, okay. And then you go this, and you go, well, this isn't a Wi-Fi device. This is actually a very low-power radio device that talks twice a day to the sensor in my oil tank, so it's an IoT device, but it actually connects to my network wired. You go, well, okay, what happens if I don't trust this wired device and I'm plugging it into my network? At that point, you go, damn, I'm going to have to physically re-architect the wiring in my house to have secure networks and insecure networks. And that's actually getting quite difficult. I'm going to start having to put in active switches because I've got these dumb switches which just packet comes in and it rebroadcast the packet to every segment on my network. So you go off, you go, okay, I'll start putting in actively managed intelligent switches. And you can buy those and you can start to say, these are my devices, and you can start to work out, let's do deep packet inspection on X11 protocol being run on my oil sensor. Okay, maybe. And then, well, let's look at some of my other devices. They're really getting quite sophisticated. What are the firewall settings I have to set up to make sure that it's going off to the internet when I want it to, and when it goes on the internet, it's going to somewhere I think is a sensible place for it logging data, and it's certainly not ever looking at anything else on my network. And then you start getting into writing firewall rules, and you kind of go, hang on, this is serious sysadmin shit. And this is just my holiday home. What is this world we're creating? How have we made it easy to make it secure? How is it going to work? I kind of think a lot of this ends up being a machine learning problem because as a consumer, there are just too many random devices that are too poorly specified to not have, they don't come with a set of rules that goes, dear owner, this is what my device does, this is who it talks to, this is how you should configure your system to do it. We've made this world insecure by design, or by the complete lack of design. We need to worry about how do we actually allow us to build secure systems. And in some ways, it's no different from what's going on in industry and business today. But the more and more of our world becomes dependent on it, the more and more the infrastructure of our towns and city rely on this infrastructure in my house working, the more we have to worry about it. And I don't think we're doing a good job of solving that problem. But all of this, of course, I'm probably horribly over time. All of this, of course, took me to Cambridge Analytica, which you'll have read about, and the word Cambridge is in there, so we have to worry about it. And I started reading up about Cambridge Analytica, and there was one thing I found really, it was either deeply reassuring or deeply depressing, was who broke the story? Old-fashioned journalists. Guardian and New York Times. This wasn't bloggers. This wasn't people who get paid to post adverts on their news feeds. This was old-fashioned journalists who get paid to do what they do, who actually went off and did the homework and did the research. And I say, as a person who still has the newspaper tangibly delivered to my house every day, I found it deeply reassuring. But I find it slightly troubling about how does investigative journalism play out into the future. But again, I'm not allowed to do politics. So old-fashioned journalists. And as I was reading the article, I then also thought, well, okay, I do like mid-century Danish furniture. I've bought quite a lot of it. It's true, right? It's true. And you kind of think, oh, well, I kind of understand how targeting ads work. And then you thought, well, do I? I'm on the Guardian website, and how did this actually work? So I actually started to do some work to understand how does all that targeted ad stuff work. Took me to look into an example here. Here's a shopping app. A real app, 300 million users. And And it needs a data platform that collects data from these 300 million users, about 100 million a day who are actually doing things. And that instrumenting that app takes 25 billion events a day. What I found interesting about these shopping apps is, and I hadn't, people in the industry know, but I hadn't appreciated, is different people actually have very different versions of the data presented to them. So two different people, both looking at Danish mid-century furniture, can get very different views of what they're being presented. And live on hundreds of millions of people, you run A/B comparisons as to which is a more effective, which gets more click-throughs, which gets more sales. And I thought it was a really interesting dynamic world. It's what happens on the web all the time. And I hadn't thought about that actually taking place and happening. And it made me rethink about what some of IoT is. Because if people had asked me before about IoT, you'd go, well, it's about connecting devices into the cloud so you can run this analytics. And then you think that's a fairly passive view of the world, because actually what's going to happen in future is you've got your heating app running on a set of buildings. You'll actually kind of go, you know what, I'll run completely different control algorithms on different buildings simultaneously. And then I'll actually correlate what was the energy usage, how happy were customers when they filled in satisfaction surveys, and I'll actually start running dynamically what happens inside buildings will change depending on how these A/B comparisons took place. And for me, that kind of moved IoT from being this, I will collect and analyze, into a much more dynamic system that actually changes the behavior on the end device, dependent on what's happening in the world. So this is a big data problem, right? And what's interesting, of course, is this is a big data problem that actually runs on an ARM platform, because we acquired the company a few weeks ago that provides the infrastructure to do this. And it's big data analytics because 25 billion events a day is not something that you can just knock up a little database and have and run and scale. That actually requires serious amount of infrastructure. And everyone talks about how IoT is going to produce 10 times as much data as all of these things that happen on the web today. Well, you know, let's start with what's then a small data problem, because the IoT big data problem is going to be even harder. And of course, coming back to this life of crime, a lot of the ads you see and the revenue made from showing ads is actually being fraudulently generated, because you have these bots that are pretending to be humans that click to generate pull-through. And so there's an awful lot happens in the ad industry to how do you detect who human actors are rather than non-human actors. And again, if you think about creativity, all of those things that are happening in the web today are the kinds of crime that we're going to have in IoT in the future. And if there is a way in your business model for IoT, you have subsidized the device because of the service, or the use of the service provides some benefit, there's going to be someone out there who's trying to change how that happens. And you know, if we just touch for a moment on healthcare, because I had to have one link through, then, you know, we have to worry about consent. We have to worry about identity. Is it me that is doing all of that exercise, or is it my Fitbit on my dog running around doing all that exercise? And that's the kind of thing where, you know, we will need to actually make sure that the data being generated is what it purports to be, and we have to have trust. Now, couldn't get through without doing a Spectre meltdown thing. Again, a little bit of research help here, please, on how to fix architecture issues, microarchitecture issues. There's a lot here. But I think the most interesting thing, you know, with my techie hat on rather than my business hat on, out of Spectre Meltdown was people coming to us asking for patches. So we kind of put out patches for Spectre Meltdown for the last 3 years of Linux kernels. And then we had people saying, yeah, but I've got a kernel that's 12 years old. Please give me a Spectre Meltdown patch for a Linux kernel that's 12 years old. And you kind of go, just like to point out that if your Linux kernel is more than 2 years old, there's at least 100 vulnerabilities in it that are probably easier to exploit than Spectre Meltdown. Perhaps what you ought to do is update your Linux kernel. Oh, no, we need a Spectre Meltdown fixed. Okay? So updating of devices is an absolutely critical thing. And that's why you'll have seen ARM develop a whole bunch of server-side software in order to manage devices. And management of physical devices is about how do you make it really easy for the person that's designed some IoT or embedded device to actually keep that platform updated. Because it's clearly too hard at the moment because most people aren't doing it. So a platform that allows device management is really important. And so this is an example of a relatively small IoT example of take vehicles, instrument them with a device that will tell you how fast you're going, have a camera to take pictures, and let a fleet operator run it. You have some live data because you have to connect live data from the cars or the vans, and you have to take live data from mapping changes and the weather. And you join that all together. We have a connectivity platform these days to make it easy for people to just take mobile phone devices and connect devices onto the internet. 20,000 devices, 64 gig of data a day just from instrumenting those devices. So again, it's a huge data ingest problem. Non-trivial to ingest that data and do some processing of it so that when you actually want to start querying it, and getting logistics data out of it, that data has already been sorted and arranged and indexed before you quite know what questions are going to be asked of it. So it's not just a question of sucking it in, it's a question of sucking it in and then processing it, because later somebody's going to ask questions about it. And your data comes in as a time stream, but you maybe want to then look at that data in a completely different lens by device rather than via time, or you might want to say, what is happening in my devices at this particular time throughout the world. And so the fleet operator can then run diagnostics on it, logistics, where is my package, is it late, is it on time? But also it's about creating a platform that allows you to share data, because one of the big costs for any logistics company is actually the insurance that you provide. So can you actually then provide data into insurance providers that allows you to write lower premiums? And that might be live data because you've had an accident and you want to notify the insurance provider straight away, or it might be trip statistics. So you end up saying, this driver drives well and has had no accidents, we want a lower insurance rate, please. So pulling that all together actually creates a remarkably complicated platform. And you then have to run your ML application on top of it. It's the ML application that actually live in the fleet operator, who then decides that they want to extract some small subset of that data. It'll still be vast data sets, but it'll be, we're only going to look at driver statistics now, and then run some machine learning task on that within their own cloud. So we're not trying to provide the ML solutions for everyone, but the infrastructure that plumbs this together, that intimately understands the security architecture of the chips you've connected to it in secure communications, is kind of that underlying platform that takes the ARM architecture from being the CPU architecture that everybody uses, which makes it easy to just develop your software and innovate on top of that, to what is your IoT platform that everyone uses, that allows people to go, well, actually, I'm going to go and create an Uber business model, right? Their innovation is over here on business model. It just happens that you might want, this is actually a Japanese trucking company, you might want to actually take your data from all of these devices. So building complex data platforms is important. So what's next? I don't think there's any slowing down in product innovation. We have no fears about that. Don't worry about Moore's law. There's plenty of innovation to be done, both at the silicon, device, circuit, chip, all the way through to infrastructure and services on top of that. So consumer products, there's no slowing down. Data is the new horizon. It's already here, okay? So big data problems exist in the whole mobile industry today. That technology now gets applied to upcoming things like IoT. It is a new frontier, but it's already arrived. And if you don't do it in a way that builds security and trust, then the business models don't scale, the revenue isn't there to be made. So with that, I hope that you have enjoyable and productive research summit, and the next 2.5, 3 days are valuable for you. Thank you. Now, am I supposed to answer questions or get... You can answer questions if you like. Does anybody have any questions? Anyone? Apart from the journalists, I'll talk to you later. Sorry, analysts. No questions? Great. So, let's move on. And Hai-Yan is here from Microsoft Research Center. I'm not going to introduce her beyond saying welcome and thank you very much for coming.